All right, well, we're going to look at Newton's second law now, which definitely involves a situation where acceleration is not zero. And why would that be? Well, here is an object described through a free body diagram, and there's two forces acting on it. One we're going to call force 1, and it is in the positive direction, positive 3 newtons, and the other force is working against it, force 2, negative 2 newtons. You might think of maybe two people pushing on a box that's on some ice somewhere, and one's pushing one way, one's pushing the other way. So what we end up having is an unbalanced force acting on the object, or force unbalanced, FU for short. But FU is kind of rude, so they don't use that terminology. Instead of saying there's an unbalanced force, more force in one direction than another, what scientists like to say is that there's a net force acting on the object. Same thing if you have a paycheck and you get your gross pay, and then there are taxes and deductions, and what's left is your net pay, pluses and minuses there on your check payment when you get paid. So same thing for net forces. What you do is you say the net force is equal to the sum of all forces acting on an object. Or if you want to write it as an equation, net force is equal to force 1 plus force 2 plus force 3, and on and on and on if there were more forces. Now, another way of expressing this mathematically is by using this symbol right here, sigma, which is the mathematical way of saying there's a sum. We're adding things together. You might have learned sequences and series in math class, right? This is just a series. So net force is the series where you add up all the forces. Now, in this particular case right here, we say that we look at the free body diagram and there's only two forces acting on it. Force 1, positive 3 newtons. Look, I put direction, magnitude, and unit all within a bracket. And force 2, negative 2 newtons. Look what I have here within the bracket, direction, magnitude, and unit. And when we add these together, we get positive 1 newton. So this object, and looks like this object has a mass of 1 kilogram, all right? This object has a net force of positive 1 newton acting on it. There's the direction, there's the magnitude, and there's the unit for force, newton. So what Newton really wanted to emphasize during his second law is that there is a connection between net force and acceleration. They have the same direction. Meaning, if you go back and look at this diagram here, since the net force is in the positive direction, this object would be accelerating in the positive direction. The other thing that Newton realized is that the larger the net force, the larger the acceleration. So if we had not a net force of 1, but of 2 or 3 or 4 or 5 newtons, as the net force increased, the acceleration increased. A lot of students want to make a connection between net force and velocity. That is not the direct connection. The direct connection is between net force and acceleration. That's one of the things that Newton realized. The other thing that Newton realized is that there's a connection between net force and mass and how they interact with each other to see what acceleration an object will undergo. And what was discovered is that the more massive an object is, the more net force is required to have some type of acceleration, which is basically saying it's harder to move larger objects, which you've probably known your entire life. The bigger an object is, the harder it is to accelerate, to change its motion. And Newton brought all of these ideas together in probably the most important equation in physics, that the net force acting on an object is equal to the mass of that object multiplied by its acceleration. Now take a look here. Net force is a vector. Mass is a scalar, and acceleration is a vector here. So look, if you've got a vector on one side of the equation and another vector on the other side of the equation, you've got an equal sign here. The direction here has got to equal the direction there. And that's where this statement comes into play. The other thing it's really important to take a look at is how are the units related? Well, the unit for net force for all forces is the Newton. The unit for mass is the kilogram, and the unit for acceleration is meter per second squared, which means that if you break down the Newton into its basic form, way back we learned about the 7 base units and all other units were derived from them. If you break down Newton into its base form, it's a kilogram times a meter per second squared. Well, let's try an example here. There is a 1,500 kilogram car that accelerates from positive 10 meters per second, so there's a direction, to positive 20 meters per second in 5 seconds. Calculate the net force acting on the car. Well, what we do is we draw a free body diagram first. And there's the force of gravity acting on the car because it's on the earth, so force of gravity, also known as weight. There is the normal force. That's the surface, the road supporting the car so it doesn't fall through. All right, these two, net force and force of gravity, are equal in magnitude but opposite in direction. I can draw that for you right here. Equals negative force of gravity. They balance each other out. And some type of frictional force acting on the car as well. Oh, I have it written right here already. That's okay. So what is force drive? Well, that's the engine working with the tires as it grips the road to make the car go forward. Now, let's write out what F net means. Well, F net is equal to the sum of all forces acting on the object. In this case, it's car. So that would be force drive plus force of friction plus the normal force plus the force of gravity. That's writing out the sum of all forces acting on an object, and this is a very important equation to write when you are studying dynamics problems. If you take a look at this though closely, these two cancel out, normal force and force of gravity, because they're equal in magnitude but in opposite directions. So what's left when they cancel out is that the net force is equal to the drive force plus the force of friction. But remember, we want to calculate net force, and I don't see any information about the drive force, and I don't see any information about the force of friction. So I need to calculate net force in a different manner. Well, let's write out Newton's second law. That's also an equation that contains net force. These equations both contain net force, and that's very important to keep in mind as you move forward to other problems. These two equations are always closely connected with each other. F net, sum of all forces, and F net is equal to mass times acceleration. Well, let's see if this will allow us to calculate it. Well, we know the mass is 1,500 kilograms, but I don't know the acceleration. Is there a way to calculate the acceleration? Yes, there is. I could use this equation right here from our kinematics unit. Acceleration is final velocity minus initial velocity all divided by time. And so that would be 20 meters per second minus 10 meters per second all over 5 seconds. Let me just adjust that so it looks nicer. There, that looks better. That's a better substitution. So final velocity is positive 20 meters per second minus the initial velocity, which was positive 10 meters per second. Look, I put the direction, the magnitude, and the unit all within a bracket. Same thing here, direction, magnitude, unit, all within a bracket. And this is not a vector time in the denominator, so I just put in 5 seconds. I do my calculating, and I get an acceleration of positive 2 meters per second squared, which I can now plug into my equation, F net equals ma, and I get an answer of 3,000 newtons in the, let me fix this, in the positive direction. So we've calculated F net using F net equals ma. We couldn't use this equation. We had to go this way, but sometimes this is a way to solve these questions. It's just not this situation. And there we have it. So I hope you've going to read the textbook section on this area. I'm going to ask you once again to watch some of the videos that I've posted, answer the homework questions, which I'm happy to help you with if you run into difficulty. And that is Newton's second law.